Welcome back to AI Podcast. I'm Ethan, and today we're unpacking a 2024 paper called Large Language Models Enable Few-Shot Clustering. The short version is this: with just a handful of examples, a language model can generate helpful hints that make ordinary clustering work better. The most reliable move is to ask the model for key phrases before you cluster, which is inexpensive and consistently effective. Using the model to label pairs of items can also work well, but needs more queries. Fixing clusters after the fact adds only a little.
I'm Maya, so the headline is, Fewer Examples, Better Clusters, Thanks to a Language Model. Who led the study?
It's led by Vijay Viswanathan with Graham Neubig at Carnegie Mellon University, alongside collaborators at NEC Laboratories Europe. Other co-authors include Kiril Gashteovski and Carolin Lawrence. Strong Applied NLP Group.
All right, before we dive deeper, can you set the stage? What problem are they actually trying to solve?
Clustering groups similar texts without labels, useful for things like support tickets or customer queries. The catch is that clustering is underspecified. There are many reasonable ways to group the same data, and without guidance, the algorithm might pick the wrong perspective. Semi-supervised methods let a person give hints like must link and cannot link pairs, but that takes time and expert effort. This paper asks whether a language model can amplify a tiny amount of expert input into a lot of useful guidance.
Right, those pairwise hints can get tedious fast. When you say the model amplifies expertise, what does that look like?
They try 3 plug-in points. First, before clustering, they ask the model to generate a few key phrases for each document using a short instruction plus a few demonstrations. Those phrases are encoded and combined with the document's embedding, nudging features toward what the user cares about. Second, during clustering, the model acts as a pseudo-oracle that judges whether selected pairs should be in the same cluster, and those constraints guide a constraint-aware k-means. Third, after clustering, they ask the model to check low-confidence assignments and, if needed, reassign to a better cluster.
So before, during, and after, which one is the practical winner?
Pre-clustering key phrase expansion. It's the most consistent and the cheapest. Pairwise constraints can be powerful too, especially when you can afford a larger batch of model judgments. Post-clustering correction helps mainly on borderline cases and usually adds less.
What did they test on to show this works?
2 families of tasks. First, entity canonicalization, where they group mentions that share the same surface form. Second, short text clustering on intent and tweet datasets. They keep encoders frozen, rely on standard clustering like k-means or agglomerative, and compare against strong baselines. The language model is GPT 3.5, prompted with brief instructions and a handful of demonstrations.
Quick check on that entity setup. If they only cluster items with the same surface form, they don't need to disambiguate different meanings of the same word, right?
Correct. It's a useful but simplified setting. It avoids true word sense ambiguity, which is tougher. That's a limitation to keep in mind when interpreting those results.
Got it. So, what did they actually find across the board?
Key phrase expansion is a safe default. With just a few demonstrations, the model adds phrases that capture the nuances a user cares about, and the merged embeddings improve clusters across datasets. Using the model for pairwise constraints can also match or beat human-in-the-loop methods at the same budget, mainly because the model can label many more pairs in the same time. Trying to repair clusters after they're formed tends to give modest gains.
That cost angle is interesting. So in practice, if I have a limited budget, I'd start with key phrase expansion and only then consider pairwise constraints if I need more control.
Exactly. Their ablations also show that both the short instruction and the tiny set of demonstrations matter. Removing either weakens results. And interestingly, asking an instruction-tuned encoder to follow the same instruction doesn't match the quality of the key phrases produced by GPT 3.5. The LLM seems particularly good at injecting task-specific cues into the features.
Makes sense. The model is basically brainstorming telltale phrases for each document. That's something large language models are good at.
Exactly. Another nice aspect is modularity. You don't replace your pipeline, you add a small step that works with whatever encoder and clusterer you already have.
Let's put on the skeptic hat. What should listeners be cautious about?
First, for the pairwise constraint prompting, they use a few demonstration pairs drawn from the evaluation data to simulate an expert. It's a tiny number, and just for guidance, but some readers may worry about leakage. Second, the strongest entity results rest on that same surface form assumption, which sidesteps ambiguity. Third, reproducibility can drift because the method relies on a specific GPT 3.5 snapshot and APIs evolve. Finally, the pairwise approach shines when you can query the model a lot. Under strict budgets, you may not reach that regime.
Those are fair caveats. If I'm a practitioner, how should I decide which touchpoint to try first?
Start with key phrase expansion. It's simple, low cost, and reliably helpful. If clusters still look off and you need cleaner boundaries, try a batch of model-generated pairwise constraints and feed them to a constraint-aware k-means. Treat post-clustering correction as optional. It can nudge a few edge cases but rarely moves the needle as much as the other two.
Can you give a concrete example of key phrase expansion helping?
Sure. Imagine intent clustering for a support chatbot. You give 2 or 3 examples of billing issues and password reset. For a new query like got charged after canceling, the model might add phrases such as subscription, refund, and cancellation fee. Those cues make billing-related queries cluster together and stay separate from password questions, so k-means has an easier job.
That's intuitive. And if I go the pairwise route, I'd ask whether charged after canceling and double billed this month belong together, building up must links and cannot links to guide the clusterer.
Exactly. They also use a simple strategy for choosing which pairs to ask about. First, explore diverse, far-apart items to find cannot links, then consolidate nearby items to find must links. It's not fancy, but it's practical.
What does this mean for teams sitting on a lot of unlabeled text?
It suggests a low-friction way to inject domain knowledge. You don't have to label thousands of examples or fine-tune a model. A few well-chosen demonstrations plus LLM-generated key phrases can nudge your features toward the clusters you actually care about. If you need stronger guidance, model-generated constraints can provide a lot of mileage per dollar.
And the open questions going forward?
Better pair selection under tight budgets. Encoders that truly understand instructions, moving beyond same-string canonicalization to cases with real ambiguity, stabilizing costs with open models and caching, and testing more domains and languages. Plenty to explore.
Great. To wrap up, few-shot clustering gets a real boost when a language model expands or labels strategically. Pre-clustering key phrase expansion is the go-to move. Pairwise constraints are powerful when you can afford them. Post-clustering tweaks are optional.
That's the takeaway. Smart, simple additions that respect your existing pipeline. Thanks for listening to AI Podcast. See you next time.